Hey guys, in this lesson we're going to talk about fractions. In particular, we're going to look at simplifying, adding, subtracting, multiplying, and dividing fractions. Okay, so in math we deal with different types of numbers. The natural numbers are called the counting numbers, and basically the natural numbers are just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way, until you can't count anymore, but you can always count more. So there's an infinite number of natural numbers. So another type of number is called a fraction, and there are two parts of a fraction. The numerator is going to be the top part of the fraction, as we can see here, and the denominator is the bottom part of the fraction. Now, a fraction represents a part of a whole. So the denominator is going to represent the total parts that we have, and the numerator is going to represent the number of parts that we have shaded. So in this particular example, the fraction, the parts that we have, the denominator is going to be 5 because we have 5 pieces in the whole. So 1, 2, 3, 4, 5. 5 pieces of the whole. So that's the denominator. And the numerator is going to be how many pieces are shaded, and that's 2. We can see that. So 2/5 is how we would say that fraction. So a proper fraction, by definition, is a fraction whose numerator, so the top, is smaller than the denominator, the bottom. And what a proper fraction represents is a number that is bigger than 0 but smaller than 1. So some examples of proper fractions. The first example is just the fraction listed 3/5. And we know it's proper because the numerator 3 is smaller than the denominator 5. We have some other proper fractions here. 1/2. Again, this is a number between 0 and 1. It's actually right in the middle if you were to plot 1/2 on a number line. So here's 0 on the number line, here's 1, and 1/2 is going to be smack dab in the middle right there. 1/4, so 1 out of 4 pieces is shaded. Now 1/4 is going to be, it's going to be between 0 and 1/2. So if we were to plot 1/4 on a number line, it would be right there. 3/4 is going to be 3 shaded parts out of 4 total parts, and that is going to be bigger than 1/2 but less than 1. So 3/4 is actually right here. And we could do the last 3 in a similar way. So all of these are proper fractions. They're numbers that are between 0 and 1. They're part of a whole. And the numerator is always going to be smaller than the denominator. So let's practice writing some proper fractions. So we can see that the first one is done for us. We have 1 piece shaded, that's the numerator, and there's 5 total pieces in the pie, so that's our denominator. 1/5 is how we would say that. So this one, how many total pieces do we have? We have 4, so that's the denominator. And how many are shaded? We have 1, 2, 3 are shaded, so that's the numerator. Here we have 2 shaded out of 3 total pieces. Here we have 1 piece shaded out of 2 total pieces. Here we have 3 pieces shaded out of 1, 2, 3, 4, 5 total pieces. 1 piece shaded, numerator, out of 3 total pieces. 1 piece shaded out of 4 total pieces. 2 pieces shaded out of 1, 2, 3, 4, 5 total pieces. 1, 2, 3, 4 pieces shaded out of 5 total pieces. And finally, 2 pieces shaded out of 4 total pieces. So that's how we can represent these pictures with fractions. So the next thing I want to talk about is improper fractions. Now, improper fractions are numbers that are bigger than 1. And we call them improper because the numerator is larger than the denominator, whereas with proper fractions, the numerator was smaller than the denominator. Improper fractions are the same thing as mixed numbers. We can interchange between the two, and we'll do some practice there. So let's take a look at what an improper fraction looks like in a picture. So I'm looking at this picture right here. We have it looks like pizzas or something. And so we have 1, 2, 3 total whole numbers, right? So we have three entire pizzas, and then we have a proper fraction left over. So the first way that we can see this is as a mixed number, right? We have 3 whole parts. That's where this 3 comes from in the mixed number. So this is our mixed number. So the 3 represents how many wholes do we have, and then the proper fraction is going to represent how many parts we have here. And we can see that 1, 2, 3, 4, 5, 6 is our denominator, and our numerator, how many are shaded, is going to be 1, 2, 3, 4, 5. So that's why our numerator is 5 and our denominator is 6. So this part represents the 5, 6. And actually, maybe I should have written it like this. This is a whole, this is a whole. And so when we add all of these guys up, 1 plus 1 plus 1 whole plus 5, 6. Well, 1 plus 1 plus 1 is 3, and then we just put the 5, 6 next to it. So that is our mixed number version here. We can also look at this in a different way. We can look at it as an improper fraction, and to do that, we just count the number of total pieces we have without accounting for the wholes. So for the improper fraction, we just count the pieces, and since all of my wholes are divided into 1, 2, 3, 4, 5, 6 parts, we're just going to count the amount of sixths that we have. So we have 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6s, 9 6, 10 6, 11 6, 12 6, 13 6, 14 6, 15 6, 16 6, 17 6, 18 6, 19 6, 26, 21 6, 22 6, 23 6. So that's where this is coming from. So this is our improper fraction because the numerator 23 is larger than the denominator 6. So keep in mind these two things are the same thing. 3 and 5 6 represents the same number as 23 sixths. Okay, so let's do some practice converting between improper fractions and mixed numbers. So 13 fourths. We can do this pictorially. I'm also going to show you a little shortcut for doing this. So what we're given is an improper fraction here because the numerator 13 is larger than the denominator 4. And I can just do a quick picture here. I see that my pies should be divided into fourths, right? And so if we have 13 fourths, well, I can make some fourths right here, and I know that. Let's see. So each one of these wholes is how many fourths? Well, it's going to be 4 fourths, right? So this is 4 fourths. This is another 4 fourths. I don't know if I'm spelling this right. Does fourths have a U in it? I'm not sure. I don't think it does, actually. Oh well. Good thing I'm not an English professor. Okay, so 4 fourths plus 4 fourths plus 4 fourths. How many fourths is that? Well, 4, 8, 12. That's going to be 12 fourths. This is 13 fourths, so we need one more fourth. Shaded. So how can we write this as, so what I have pictorially is 13/4. Count each piece, and the sum of the pieces is going to be 13. And the 4 is because we cut our pies into fourths. Now, what is this as a mixed number? Well, for mixed numbers, we count the wholes. So we have a whole here, a whole here, a whole here, and then our last one is going to be a part. So we have 1 plus 1 plus 1 plus, and the last one is a fourth. Adding these together, we get 3 and 1/4, so that's our mixed number. That's our answer. Now I want to show you a shortcut, so you don't have to draw the picture every time. The shortcut is we just do the division. This fraction bar also means division. And so what we can do is we can put 4 into 13. See how many times that 4 goes into 13. So I know that 4 goes into 13 3 times, and 4 times 3 is 12. So I subtract 13 minus 12 and get a remainder of 1. And so as a mixed number, we take this number on top, and that's our big number. And then the remainder is the numerator of the part, which is 1. And the denominator is going to be this number on the outside of the house. So that's the shortcut. Either way, we're going to get the same answer. So, all right, so let's go ahead and look at number 2. We're going from, we have a mixed number, and we want to turn it into an improper fraction. Now, I want to show you the shortcut for this first before I show you the picture. And you should pause the video and see if you can get the picture on your own. Okay, so the shortcut is to go from mixed to improper. Is we're going to multiply the whole part by the denominator. Then we're going to add the numerator. And finally, we're just going to put it all over the original denominator. So it's easier done than said, to be honest. So let's do it. So here we want to first multiply the whole part times the denominator. So 6 times 3 is going to be 18. And we want to add the numerator to it, which is 2. And we want to put this all over our original denominator, which was 3. So 18, 19, 20 over 3 is our improper fraction here. And we can look at this pictorially as well. Let me go ahead and erase some stuff so we have room. So we have 6 and 2 over 3 was our original number. And we know now that the improper fraction representation is going to be 20 over 3. 6 times 3 plus 2 over 3. We can also look at this pictorially, right? Because it says that there's 6 wholes, right? And by the way, we're dividing it by 3 because of the denominator's 3. So we have 6 wholes. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then the part is going to be 2/3. So 2/3 is going to be shaded here. And then the rest are all going to be shaded. Okay. So how many thirds do we have? We have 6. Well, no, we have 6 wholes, and we have 3/3 in each whole, right? So we have 6 times 3/3, right? And that's going to give us 18, right? 6 times 3 is 18 thirds. So the wholes make up 18 thirds, and this part, we have 2 thirds. And altogether, that's going to give us our answer of 20 thirds right here. So that's how we can do that pictorially. All right, the next one we have 9/8. 9/8. So let's go ahead and do the division because we're given an improper fraction and we want to go from improper to mixed. So I'm going to divide 8 into 9. So we're going 8 into 9. 8 goes into 9 once. 8 times 1 is 8. 9 minus 8 is 1. And so this is going to be 1 and 1/8. Okay, as a mixed number. 1 and 1/8. So once again, the answer that we get is our mixed number. The remainder is going to be our numerator, and the outside number is going to be our denominator. So this is our answer as a mixed number. 1 and 1/8. We can also draw pictures if we want. Now 5/6, that's a proper fraction. It's not improper because the numerator 5 is less than the denominator 6. So you know, we can do this a couple of well, there's really no other way to explain it other than since this is proper, we're going to have 0 whole parts and 5/6 fraction parts, right? 0 and 5/6. We don't have to write the 0, so this is just 5/6. This is a since it's a proper fraction, we can't write it as a mixed number because there's no holes to go, right? So we only have, five, I'm not going to draw that. We only have 5/6. What about number 5? So how many holes do we have? Well, we have a hole here and we have a hole here, and then we have a part represented by this piece. So what's the part? The part is, there's one piece shaded out of 3 total parts, so that's 1/3. So as a mixed number, we just smush all the numbers together. 1 plus 1 is 2. 2 plus 1/3 is 2 and 1/3. So this is as a mixed number. And for the improper fraction, we can just count the amount of thirds that we have, or we can do the trick where we multiply these guys and add the top to get the new numerator. So if we do that, 2 times 3 is 6. 6 plus 1 is 7, so that's the new numerator, and it stays over the denominator. We can also look at this pictorially. How many thirds do we have? 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. All right? So mixed and improper, we can go in between them like that. Let's do number 6. So how many holes do we have? We have 1, 2, 3 holes, right? And the part that we have, well, we have 2 shaded out of a total of 4. So this is going to be 3 2/4. Yes, you can reduce it if you want, but I'm not going to do that right this moment. We're going to talk about that in a couple of slides. So let's mix as an improper. Again, we can do our trick. 3 times 4 is 12. 12 plus 2 is 14. That's our new numerator over the original denominator, 4. And once again, you can count. How many fourths do we have? 1/4, 2/4, 3/4, 4/4. There's 4 fourths, and there's 3 of those. So there's 12 total fourths here, plus 2 more, 13, 14 fourths. All right. All right, what about number 7? How many holes do we have? Well, it looks like we have 2 of them, and we don't have any parts. So this is just simply 2, right? 2 and 0/4, or just 2. So this is our mixed number. Not really mixed, but anyway. And for our improper, we can count the amount of pieces that we have, and it looks like each hole is divided in eighths. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, and then we have another 8/8 over here. So in total, we have 16/8. So this is our improper. And what's cool about this is that the fraction bar works as a division sign. So 16 divided by 8 we know is 2, right? So that's improper and mixed. All right, here we go again. We have 3 and 5/8. I'm just going to use the trick because it's faster. 3 times 8 is 24. 24 plus 5 is 29. So 29/8. This is my improper version, as I was given mixed. All right. Next one is 7 and 1/4. So my trick, 7 times 4 is 28. 28 plus 1 is 29. That's my new numerator. 29/4. We keep the same denominator here. All right, now we have 12/7. This is improper. We want to go into mixed, so I need to do my division. How many times does 7 go into 12? Well, 7 goes into 12 once. 12 minus 7 is 5. So I get a remainder of 5. So as a mixed number, this is going to be 1. That's my answer. That's my whole number. And 5, which is my remainder here, over 7, which is this number on the outside. So this is my mixed version of this guy. And we can always check ourselves by going the other direction. So like if I take this guy and I say, well, what's 1 times 7 plus 5? That's 12. 12 over 7 is indeed my improper fraction here. So that's how you can check yourself there. All right, so let's talk about something called equivalent fractions. So equivalent fractions are just fractions that have different numbers in the numerator and denominator, but they represent the same exact amount. So let's say we have a cake, and there's a lot of different ways we can cut pieces of cake, right? So like if we have a cake and we just split it down the middle, we only have 2 pieces, right? So this amount right here can also be represented in this way, right? It's the same amount. 2/4 is the same as 1/2. We just cut the cake into fourths instead of in half, right? So it's the same amount of cake. The cuts are just different, right? Looking at the next one, if we have 6 people and we want to divide the cake in 6, we have, instead of 1/2, instead of 2/4, now we have 3/6, but again, it's still representing this same amount of cake, right? All of this is the same amount of cake, it's just different cuts. And same thing on this last cake here. If we cut the cake into 1/8, well then this amount, this half of the cake, can be represented as 4/8. So 1, 2, 3, 4 pieces out of the 8 pieces cut. So these are all equivalent fraction because we have the same amount of cake, but they're represented a little bit differently depending on the number of cuts that they have. So we can easily find equivalent fractions by multiplying or dividing the numerator and denominator by the same number. And the reason we can do that is because when you multiply or divide by the number 1, you're not changing the expression. You might be changing how the expression looks, but you're not changing how, like, the fundamental expression. For example, if we want to find an equivalent fraction to 4/8, what we can do is we can multiply top and bottom by 2, right? We're multiplying by the same number, numerator and denominator. And the reason we are legally allowed to do this is because this equals 1. 2 divided by 2 is 1. If I wanted to multiply by 100 divided by 100, that would be 1 as well, right? So my equivalent fraction, it doesn't have to be 2 over 2. I could multiply by any number divided by itself. But the way that we can multiply fractions is straight across. So 4 times 2 is 8, straight across on top, and 8 times 2 straight across on bottom is 16. So therefore, dot, 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 that's how I say therefore, 4/8 and 8/16 are equivalent fractions. These are equivalent fractions. Basically, think about it like cake. These are the same amount of cake. Both of these are the same cake, but the slices are different. Here we're slicing the cake into 16 pieces. Here we're slicing the cake into 8 pieces. So that is what that means. Let's do some practice here. So complete the equivalent fractions. And as I said, we could find there are an infinite amount of equivalent fractions. Let's write it. There are infinitely many equivalent fractions for any given fraction. So for example, 1/2, half of the cake. I could multiply this guy by, think of any number. Think of a number between, 0 and, it doesn't matter. Any number will do. If I want to multiply this guy by 35/35. Once again, guys, 35 divided by 35 is 1. So this is completely legal. When I multiply straight across, 1 times 35 on top gives me 35. And 2 times 35 on bottom is going to give me 70. And therefore, 35/70 is equivalent to 1/2. These are the same thing. This is a cake with 70 pieces, 35 shaded, and that's the same thing as a cake with only 2 pieces and 1 shaded. These mean the same thing, and there's infinitely many of these because there's infinitely many numbers we can multiply them by, right? So that's a little side note. Let's do some of these. We're not going to do all of them, but let's just do some of them to get the hang of it. Let's look at the first one. We want to find an equivalent fraction to 5/10, and it says that the denominator of this equivalent fraction is 90. So since we're given 2 bottoms right here, we want to say, well, what did I do to the bottom? I have to do the same thing to the top in order to multiply by 1. So on the bottom, I multiplied 10 by 9. If I multiplied the bottom by 9, I better do the top by 9 as well. So 5 times 9 is 45, and therefore 45/90 is the same thing as 5/10. It's the same amount. Let's do number 2. So here I'm looking at the bottom. 4 times what is 20? Well, 4 times 5 is 20. So I do the same thing at the top, right? I'm multiplying by 5/5. I'm multiplying by 1. So 2 times 5 on top is going to give me 10/20. 2/4 is the same thing as 10/20. We can also, I'll cover that later. But, all right, let's look at the next one. We have 3/7 is equal to what over 28? Well, on the bottom, how did I get from 7 to 28? I had to multiply by 4. So I do the same thing to the top. 3 times 4 is 12, and therefore 12/28 is equivalent to 7/28. All right? Okay, so let's look at this one right here. We have 6/something is equivalent to 30/45. Since I'm given both of the tops here, I'm going to use those. And it says 6 times what is 30? Well, that's going to have to be 5. So whatever I do to the top, I have to do to the bottom. But since we're going from left to right, we actually have to, well, you know what? Maybe we should write it like this. Maybe we should say, we should write it like this. We should say 30/45 is equal to 6/something, right? Same thing. I just rewrote it. And now we can see the relationship from going left to right is division, right? So here, to get from 30 to 6, we have to divide, right? It's going from a bigger number to a smaller number, so we have to divide by 5, right? If I divide top and bottom by 5, I get 6 over 9. So 6 over 9 is the same thing as 30 over 45. So we can divide as well. Let's go ahead and look at this one right here. 4 over 4 is equivalent to what over 12? Well, on the bottom, I have to multiply by 3. So 4 times 3 is going to give me 12. And on top, I have to do the same thing. So 4 times 3 is going to give me 12. Therefore, 4 over 4 is equivalent to 12 over 12. Let's do one more. Let's look at this guy. So I'm going from 12 to 6, right? So 12 to 6, what do I have to do? I have to divide, right? So 12 divided by what is 6? That's going to be 2. So I have to do the same thing in the top. So 4 over 12 is the same thing as 2 over 6. All right, so hopefully those examples made sense. Maybe we should do one more. Let's do this one. So on the bottom, 7 times what is 28? Well, that has to be times 4, so I do the same thing in the top. So 1 over 7 is equivalent to 4 over 28. All right, so a fraction in simplest form is the smallest possible equivalent fraction of the number. When we say we want to find a fraction in simplest form, we'll say either reduce or simplify. So let's look at some examples here. So simplest form, we're going to divide as much as we can until we can't anymore. So for example, let's look at number 1. I'm going to just project it over here so we have more room. I want to start by dividing the biggest number I can think of that will divide both 18 and 42. And, if the biggest number you can think of is 2, you can do that. You're just going to have to reduce more than you'll need to, I guess. So the biggest number I can think of that divides both 18 and 42 is 6. So if I divide top and bottom by 6, again, I'm simply dividing by 1. Just want to make sure you guys are clear on that. 18 divided by 6 on top is going to give me 3, and 42 divided by 6 on bottom is going to give me 7. Now, 3 and 7 can't be divided anymore. 3 doesn't go into 7. So that's it. This is my answer in simplest form. So this is going to be 3 over 7. Now, let's say I couldn't think of 6. Let's say I was like, okay, well, they're both even, so they can both be divided by 2. Let's start this process over. If I divided instead top and bottom by 2, well, on top, 18 divided by 2 is 9. On bottom, 42 divided by 2 is 21. And I would say to myself, well, 9 and 21 have a number that will divide both of them evenly. And that number's 3. So we would go again. We would divide 9 over 21 by 3 over 3. And 9 divided by 3 on top gives us 3. 21 divided by 3 on bottom gives us 7. So we end up getting the same answer no matter where we start. We just had more steps in the second instance because we didn't divide by the highest number that they could be divided by. All right, let's do some more examples. I'm just going to do a few more of these. Let's go ahead and look at this one, 16 over 24. So 16 and 24, I'm thinking these guys can both be divided by 8 evenly. So if I divide top and bottom by 8, 16 divided by 8 is 2, and 24 divided by 8 is 3. And I cannot go any more. So my answer here is 2 over 3. Let's look at number 12. Number 12, we have 14 over 20. I'm just going to start by dividing top and bottom by, 2. So 14 divided by 2 is 7. 20 divided by 2 is 10. This can't be reduced anymore, so our answer is 7 over 10. Let's do one more. Let's do number 17. So we have 40 over 64. And I know both of these numbers can be divided by 8. So if I divide top and bottom by 8, 40 divided by 8 on top gives me a 5, and 64 divided by 8 on bottom is going to give me an 8. So my answer here is 5/8. So the next thing we're going to talk about is adding and subtracting fractions with unlike denominators and like denominators. So let's say we wanted to do 1/2 minus 3/8. How would we do it? Well, pictorially, it doesn't really make sense in our minds, right? Because this guy is cut only into 2 pieces, whereas this guy right here is cut into 8ths. And if you're trying to take 3/8 away from 1/2, it doesn't really make sense. So the strategy here is to get an equivalent fraction so that the same number of pieces is present, so we can add and subtract. And so that's what we're going to do down here. It says we need the same amount of pieces to add or subtract. And now this makes more sense in our head because we changed 1/2 to be cut into 8 pieces, right? It's still 1/2, right? It's still half of the cake. We just cut it into 8 pieces this time. And what we want to do is we want to take 3/8 away from that. So 4/8 is the equivalent fraction, right? 1/2 is secretly 4/8, and we can see that 1, 2, 3, 4 out of 8 pieces. So we're taking 4/8, take away 3/8. So what we're taking away is 1, 2, 3. And how much are we left with? Well, we're left with 1/8, right? So 4/8 minus 3/8, we're left with 1/8. So the big thing that students will get wrong when adding and subtracting fractions is they just go straight across like multiplication, but that's not correct. So whenever you add or subtract fractions, I want you to think of these cakes with different pieces and how we can't add or subtract them unless they have the same amount of pieces in each cake. So yeah, again, that's what students mess up with. If they have one common mistake is if you have 1/3 plus 1/2, students will just go straight across and say, well, that's going to be 1 plus 1 is 2, 3 plus 2 is 5. And that's a big no here. We can't do that. We have to make sure that we have the same denominator. We have to have the same amount of pieces, okay? And we know how to get the same denominator. We just change one of the fractions into an equivalent fraction that has the same denominator as the other one. So let's do some practice here. So I mentioned up here we can add or subtract fractions if the fractions are equivalent, all right? So take a look at this. We have 1/3 plus 1/6. And right now, if you envision this, okay, we have 1/3, which is this, and then 1/6, which, oh man, I can't draw a 6 very easily, but let's try it out. Let's see. 3. I'm not the best at drawing these fractions, but it's okay. That'll do, I guess. So we're taking 1/3 and adding a 6, and you're like, what is that going to be? 1/3 plus 1/6? I'm not really sure. So we need to turn one of these fractions into to have the same amount of pieces as the other one. And the easiest way to do that is with this one, right? Because I'm looking at the 3 and I'm saying, oh, I can easily change that 3 into a 6 with multiplying by 2, right? So what I'm going to do is I'm going to change this guy. I'm going to change this guy to have 6 pieces instead of 3. All right, so that's what I want. So originally I have 1/3. I want him to have a denominator of 6 so that I can add these guys. So what do I have to multiply on the bottom? What do I have to multiply 3 by to get 6? I have to multiply by 2 So I do the same thing at the top. Again, I'm just multiplying by 2 over 2. I'm finding an equivalent fraction so that I can add these guys. 1 times 2 on top is going to give me 2. So 1/3 is secretly 2/6, right? So this guy, this 1/3, and maybe I'll actually draw it down here, just so you guys can visualize it a little bit better. This 1/3 is secretly 2/6. Right, so let me draw this. So this 1/3 is actually really this when we cut it up more. And now we can see what's happening here. It's pretty cool. So we're adding 1/6 and 2/6. And when I add these, it's pretty clear, right? If I add one piece over to this side, I'm going to get 3 pieces, right? So 2/6 plus 1/6 is equal to 3/6. And I can simplify this. I can get a smallest equivalent fraction. And the way that I do that is I can divide top and bottom by the greatest common factor, the biggest number that we can think of that divides both 3 and 6, and that number is 3. So if I divide top and bottom by 3, I'm going to get 1/2. And this is my fully simplified answer here. So just to recap, when we add fractions with different denominators, we need to change one fraction into an equivalent fraction that has the same denominator of the other. Here, we chose to change 1/3 into 2/6, right? We just made it look different by cutting the pieces. Once we do that, we can just keep the denominator and add the top. So 2/6 plus 1/6 is 3/6. And once we got that, we simplified fully by dividing top and bottom by 3. So our final answer is 1/2. And this makes sense, right? Because if we think about this, when we combine these, when we add the first pi plus the second pi, what we get is half the pie, right? We started with these 2 pieces. We're adding this 1 piece to the 2 pieces. And so that's going to give us a total of 3 pieces. And yeah, this is definitely 1/2 of the pie. All right. Very cool. Okay, so that was that one. So our answer was 1/2. Now, I'm not going to draw the picture for all of these. I just wanted you guys to see the visual behind this, why it works, why it makes sense. So let's go ahead and look at number 2. I didn't really label it as number 2, but we have 7/10 minus 3/8, okay? And we want to either change 8 into 10 or 10 into 8, and I can't really think of a way to do that without using decimals. So when you are in this situation where you can't turn a 10 into an 8 and you can't turn 8 into a 10, or whatever the numbers may be, you can simply get a common denominator by multiplying the 2 denominators, right? So the common denominator here, and we could have done this up here and just reduced, but it's easier to find to change one into the other, because right now what we're going to have to do is we're going to have to change both of these, all right? So the common denominator is going to be 80, right? Because we can't change 10 into 8, and we can't change 8 into 10, so we multiply the 2. So the first thing I want to do is I want to change 7 over 10 to have a denominator of 80, all right? So what do I have to multiply 10 by to get 80? I have to multiply it by 8. So I do the same thing to the top. So 7 times 8 is 56. And therefore, 7 over 10 is secretly 56 over 80. That's an equivalent fraction. Now, I want to make sure I change the 3 over 8 too, because 80 and 8 are still not common denominators. I want to change the 8 into the 80 next. So I take 3 over 8, and I want to change him to have a denominator of 80. So what do I have to multiply on the bottom by to get 80? Well, I have to multiply 8 times 10. So I do the same thing at the top. Multiply top and bottom by 10, and on top 3 times 10 is going to give me 30. So 3 over 8 is secretly 30 over 80. They're the same amount of cake. We just wrote them differently. Okay, and now we can just combine the top. Now I'm going to have you do use your calculator for this because we haven't talked about positive and negative numbers yet. I'm going to save that for our next lesson. But for now, I just want you to use your calculator and do 56. Oh wait, I'm sorry. This actually isn't going to give us a negative number. That's cool. Sorry, I thought it was 30 minus 56 for some reason. But if we do 56 minus 30, we're going to get 26 on top, 80 on bottom. So that's our answer, but it's not fully simplified. Remember, we want to reduce it to the smallest equivalent fraction that we can. So I'm going to start this process by dividing top and bottom by 2, since I know both of these are even numbers. So 26 divided by 2 is 13, 80 divided by 2 is 40, and I'm done because 13 over 40 can't reduce. Now, I want you to know how to do this by hand, but I also want you to be able to check yourself. So I'm going to show you on Desmos how you can do this. So all you have to do is Google Desmos graphing calculator. Okay, Google Desmos graphing calculator, and the first thing that should come up is something that looks like this. All right, so what are we doing? Our original problem was 7/10 minus 3/8. So we just put it in Desmos. We put the 7, and then we're going to do the division sign. Okay, that's going to give us the fraction bar. So this division sign over by the 9 is going to give us the fraction bar. So 7 divided by 10, and then I'm going to just kind of like move my cursor so it's like in the middle right there, minus 3 over 8. So 3, again, division bar, top right next to the 9. And I get this decimal, which I don't know what that is as a fraction, so I can click on it. And then I can click, you see the blue, how there's a fraction bar in the 1 row? I'm going to click that fraction bar, and it's going to give me my answer, 13 over 40. And that's exactly what I got here. So that's how you can check yourself on Desmos. So our answer here is 13 over 40. I'm going to erase some of this just because it's looking a little bit clunky. Okay. All right, let's do the next one. So you want to, before you start multiplying, I mean, you could say, oh, well, 5 times 20 is 100. Let's make 100 the common denominator. Yeah, you can totally do that. You can change both the 4/5 and the 1 over 20 to have a denominator of 100, but you're doing too much work, and I'm going to tell you why. The reason is because we can change the denominator of 5 into a denominator of 20. That way we can leave the 1 over 20 alone. We don't have to do as much work. Whereas up here, when we had the 10 and the 8, we couldn't change 10 into 8 with multiplication, and we couldn't change 8 into 10. So that's why we had to multiply the denominators. So what I'm going to do is I'm going to leave the 1 over 20 as it is, and I want to change 4 over 5 to have a denominator of 20 so that I can add these guys. So on the bottom, 5 times what is 20? Times 4. So I have to do the same thing at the top as well. 4 times 4 is 16, and therefore 4 over 5 is secretly 16 over 20. That's an equivalent fraction. So now this problem becomes 16 over 20 plus 1 over 20. We keep the denominator, that's just 20, and the numerators we add. 16 plus 1 is 17. So our answer is 17 over 20, and that can't be reduced anymore. Let's try the next one. We have 9 minus 2 over 3. Now, whenever you see a whole number, you want to always think that it's understood to be over 1. Okay? So we can write 9 as 9 over 1. okay? That's what that is. So 9 over 1 minus 2 over 3. So can I change a 1 into a 3? Can I change a 3 into a 1? Well, I can change a 1 into a 3 by multiplying by 3, so I'm going to change the 9. I'm going to change this guy so that I can subtract them. So let's go ahead and do that. I have 9 over 1, and I want him to have a denominator of 3 so that they have the same denominator. So on the bottom, what times 1 is equal to 3? Well, 3. 1 times 3 is equal to 3. So I have to do the same thing at the top. 9 times 3 is 27. So 9 is secretly 27 over 3, or 27 divided by 3, if you like to think about it like that. So this problem now becomes, instead of 9 over 1 minus 2 over 3, we just found out that 9 over 1 is 27 over 3. So instead of 9 over 1, we're going to write 27 over 3, and then we still have minus 2 over 3. Since they have the same denominator, we are in a position to subtract. And to subtract these fractions, we subtract the numerators. 27 minus 2 is 25, over, keep the same denominator. So our answer here is 25 over 3. Now this guy is an improper fraction, so we could write him as a mixed number if we wanted to, but I'll leave that as an exercise for you guys if you want to do that. All right, let's look at the next one. We have 2 plus 7 fifths. All right, what are we going to do? Well, the first thing we can do is put this 2 over a 1, right? That's a whole number, so we can put him over a 1. And I can recognize that I can change this 2 to have a denominator of 5, right? The goal is to get them to have the same denominator so that we can add or subtract them. So let's go ahead and do that. So 2 over 1, I want this guy to have a denominator of 5. What do I have to multiply 1 by to get 5 on the bottom? Well, I have to multiply him by 5. So I do the same thing at the top. 2 times 5 is 10. So 2 is secretly 10 over 5, which should make sense, right? This is 10 divided by 5. All right. So this problem, 2 over 1 plus 7 over 5, is actually 10 over 5 plus 7 over 5. We're just replacing 2 with 10 over 5 so that we can add. All right. So now I can keep the denominator 5 and add the numerators. 10 and 7 make 17, and I can't reduce this anymore. So our answer is 17 fifths. Again, you can check on Desmos if you feel inclined to do so. Okay, let's look at this guy. So now we have 2 mixed numbers that we're adding. What I like to do when I see mixed numbers, when I'm adding, subtracting, multiplying, or dividing, is I want to first change these to improper fractions, right? So what I'm going to do first is change this guy to an improper fraction by doing my shortcut. I multiply 3 times 4, and I add 1. So 3 times 4 is 12, plus 1 is 13, over the same denominator 4. Okay, so that's improper fraction. And then this guy over here, I do the same trick. 2 times 8 is 16. 16 plus 7 is 23. And that's over the same denominator 8. Now I can add these guys, but wait a minute, they don't have the same denominator. So I take a look and I say, can I change 4 into 8? Can I change 8 into 4? Well, I can change 4 into 8 with multiplication. So I'm going to choose to change this guy. So I have 13 over 4, and I want him to have an 8 as a denominator so that I can add them. So what do I have to do to the bottom to 4 to get 8? I have to multiply by 2, so I do the same thing to the top, and 13 and 2 is going to give me 26 over 8. So 13 over 4 is secretly 26 over 8, and 23 over 8 can just come down, and now we can add them because we have the same denominator 8. So 26 and 23 is going to make 49 over 8. So that's our answer here. Okay, so this is the easier part. When we multiply fractions, we don't have to do any of this common denominator business. We can simply multiply straight across and reduce. Okay, so that's the little note I have down here. When we multiply fractions, we multiply straight across. This is much easier than adding or subtracting, in my opinion. So if we look at the first one, we have 4 times 2 over 3. So the first thing I can do is I can rewrite the 4 as 4 over 1. And I multiply straight across. So straight across on top is 4 times 2, which is 8. Straight across on bottom, 1 times 3 is 3, and that is my answer. Pretty easy, right? All right, so let's go ahead and do the next one. We have 2 times 5 over 6. So we have 2 over 1 times 5 over 6. We can multiply straight across. 2 times 5 is 10 on top. 1 times 6 is 6 on bottom. And from here, we always want to write our answers in simplest form, okay? So we don't want to be able to divide anything out on top and bottom, but here we can divide top and bottom by 2. So 10 divided by 2 on top is going to leave me with 5. 6 divided by 2 on bottom is going to leave me with 3, and this is my answer because I can't divide anymore. All right, so I can't find a smaller equivalent fraction than that. Okay, so let's go ahead and look at this third one. So we have 9 times 7 over 8, which is 9 over 1 times 7 over 8. Multiply straight across, and we get 63 on top. 9 times 7 over 1 times 8 is 8. And that's our final answer because 63 over 8 cannot be reduced. We can't divide 63 and 8 by a common number and make it smaller. Okay, let's go ahead and do this. Multiply, put your answers in simplest form. So I want to show you a little trick here, all right? Because what we did with, let's see, it was number 2. We just multiplied straight across and simplified at the end. You don't have to do that. You can save yourself some time by cross-simplifying, all right? And the way that we do this is we just look on the diagonals to see if we have anything we can divide out before we multiply. So like 3 and 7, I can't divide anything out. They don't have any common divisors or common factors. But on this other diagonal, 2 and 8, 2 and 8 can both be divided by 2, right? So we can cross-simplify here. 2 divided by 2 is 1, and 8 divided by 2 is 4, all right? And now this makes our problem much easier because when we multiply straight across, 1 times 7, now we have 1 times 7 is 7 on top. 3 times, now we have 4, is 12 on bottom, and that is fully reduced. So if you cross-simplify all the way, you're not going to have to reduce at the end, which is going to save you some really nice time here, okay? So let's do the next one. We have 5 over 11 times 3. This is just another way to write multiplication if we don't have any symbol in between these two numbers. So I'm going to write it like this. I have 5 over 11 times 3 over 1, okay? I look on my diagonals. 5 and 1 don't have anything that they can be divided by except 1, of course. 3 and 11 are also not able to be divided by anything. So that's it. We don't have to cross-simplify. We can multiply straight across. 5 times 3 is 15. 11 times 1 is 11. And that is our final answer, you guys. All right, let's take a look at this next one. We have 1 over 8 times 6 over 7. So I look on my diagonal. 1 and 7 cannot be simplified. However, 6 and 8 can. They both have something that will divide them evenly. What's the highest number that divides both 6 and 8 evenly? Well, that's going to be 2, right? So 6 divided by 2 is 3. 8 divided by 2 is 4. Now we can multiply straight across. 1 times 3 is 3 on top. 4 times 7 is 28 on bottom. And that is my final answer. Okay. All right, let's go ahead and do this guy. So we have 3 over 5, and we're multiplying by 5 over 9. I'm just going to write it like this so that we get a hang of this. All right. So looking at the diagonals, 5 and 5, yeah, these can both be divided by 5, right? So 5 divided by 5 is 1. 5 divided by 5 is 1, right? They can both be divided by 5. Now, if we look on this other diagonal, 3 and 9 can both be divided by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And now we can multiply straight across. 1 times 1 is 1 on top. 1 times 3 is 3 on bottom. And that is my answer, you guys. Pretty neat, right? Now let's take a look at this. Now, I don't see any numbers here, but the same principles apply. We can look at the diagonal. First, I have B and B, which you can think of as numbers. You can think about them as 5 and 5, just like the previous problem if you want. But the point is, a number can always be divided by itself, all right? So what's going to happen here is both B and B can be divided by B. B divided by B is 1. B divided by B is 1. Now, if we look at this guy, well, we can basically divide out an A, right? A divided by A is 1. 2A divided by A is just 2, right? If I do 2A divided by A, these A's are going to cancel out and we're just left with 2. We'll talk more about that later when we get into the cool algebra part of this class. Right now we're just doing some preliminaries. All right, so if we multiply straight across, 1 times 1 is 1 on top, 1 times 2 is 2 on bottom, so our answer here is 1/2. Okay. We can also write multiplication problems with the word of. So of means multiplication. When I'm asking what is 1/7 of 49, what does that mean? Well, what this means is 1 over 7 times 49. All right. Now, I can put 49 over 1. And what I can do is I can cross simplify on the diagonals here. Both 7 and 49 can be divided by 7. So 7 divided by 7 is 1, and 49 divided by 7 is 7. On the other diagonal, 1 and 1, well, we can't really do anything there. We can't divide those out. So multiplying straight across, 1 times 7 is 7 on top, 1 times 1 is 1 on bottom, and 7 over 1 is simply the number 7. All right, so 1/7 of 49 is going to be 7. We could also think of this in terms of like a pie, right? So if I have that's a terrible pie, but I think you guys get the picture. Let's say this whole pie represents the number 49. And we have 7 pieces. So what we're asking is, what is 1/7? What does this piece have to be if the whole thing's 49? Well, you just divide it by 7, right? Now, dividing by 7 is the same thing as multiplying by 1 over 7. I just want to make that clear. Dividing by 7 is the same thing as multiplying by 1 over 7. Okay, so that's that. What is 2/3 of 18? So again, of means multiply. So 2/3 of 18 is 2/3 times 18 over 1. I can cross simplify on this diagonal. 3 goes into itself once, and 3 goes into 18 6 times, I'm sorry. Multiply straight across, 2 times 6 is 12 on top, 1 times 1 is 1 on bottom, but we don't have to write the 1 on bottom, it's just 12. What is 1/8 of 64? Again, multiplication. I'm taking 1/8, so this is multiplication, but it's also division. When I say 1/8 times 64, this is actually 64 divided by 8, because if I multiply straight across, 1 times 64 is 64. 8 times 1 is 8. 64 divided by 8. Hopefully that makes sense to you guys. But what I want to do instead of multiplying straight across is I want to simplify along the diagonal first, just to get used to that. Both 8 and 64 can be divided by 8. So 8 divided by 8 is 1. 64 divided by 8 is 8. Multiply straight across. 1 times 8 is 8. 1 times 1 is 1 on bottom. So my answer is 8. Okay, so let's talk about a new term that you guys have probably heard before in your school career. It's called the reciprocal. Reciprocal is just the fraction flipped. So let's do some practice finding the reciprocal. So what that means, the reciprocal of A over B is B over A. We just literally flip the fraction. So what's the reciprocal of 1 over 5? Well, we just flip it, right? So 5 comes on top, 1 comes on bottom. So that's our answer. The reciprocal of 2 over 3 flipped is 3 over 2. We just flip the order. Now 8 is secretly 8 over 1. So when we flip 8 over 1, we get 1 over 8 as its reciprocal. So let's talk about our last topic here, and that's dividing fractions. The way that we divide fractions is different from the way that we multiply them. When we divide fractions, we are multiplying the first fraction by the reciprocal of the second fraction. And you can memorize this: keep, change, flip. So what we do is we keep the first fraction, we change the division sign to multiplication, and then we flip the second fraction. So let's do some examples. If we have 3 over 8 divided by 3 over 10, we're going to keep the first fraction, which is 3 over 8. So that's step 1, keep the first fraction. Step 2 is we're going to change the division sign to a multiplication sign. And step 3 is we're going to flip the second fraction, aka find its reciprocal. So if I flip 3 over 10, that's going to be 10 over 3. And then we just multiply these guys. What I can do, since I'm multiplying, is I can cross divide. I'm looking at the diagonals here, and I see that 3 divided by 3 is 1. 3 divided by 3 is 1. And on this diagonal, both of these guys can be divided by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. Now I multiply straight across. So 1 times 5 is 5 on top, 4 times 1 is 4 on bottom, and this is my answer. So keep, change, flip. That's how we do it. Let's do some more examples. Okay, so divide and put your answer in simplest form. So we're going to keep the first fraction, which is 2 over 3. We're going to change the division sign to multiplication, and then we're going to flip the second fraction. So instead of 4 over 9, we're going to flip it to 9 over 4, and this is how we're going to multiply. So from here, we can cross simplify, or if you want to, you could multiply straight across and simplify at the end, but that's too much work in my humble opinion. If we look at the diagonals, 3 and 9 can both be divided by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3. On the other diagonal, 2 and 4 have a common divisor of 2. So 2 divided by 2 is 1, and 4 divided by 2 is 2. Multiply straight across. 1 times 3 is 3. 1 times 2 is 2, so our final answer is 3 over 2. All right, I'd like you guys to pause the video and try that one. All right, keep, change, flip. So we're keeping the first fraction, 12 over 25. We're changing division to multiplication, and we're flipping the second fraction. So we're flipping 6 over 5 to 5 over 6, and now I'm going to cross simplify. So when I cross simplify on this diagonal, I see that both 25 and 5 can be divided by 5. So 5 divided by 5 is 1, 25 divided by 5 is 5. On the other diagonal, I see that both 6 and 12 can be divided by 6. That's the biggest number that they can be divided by. So 6 divided by 6 is 1, 12 divided by 6 is 2. Multiplying straight across, 2 times 1 is 2, 5 times 1 is 5. This is our answer, you guys. So on your homework, you might see something that looks like this. No worries. Remember this bar right here, division bar just means the division sign. So I'm going to just first rewrite this. I have one fraction on top, and then this big division bar I'm going to change into the division sign. So 1/2 divided by 3/4. That's all that means. This is the same thing as this, okay? So now since I have this, I'm going to do my keep, change, flip. So I'm going to keep the first fraction, change division to multiplication, and flip the second fraction. Now I'm going to inspect my diagonals to see if I have any common things that I can divide out. 1 and 3, I don't have anything I can reduce there. But 2 and 4, both 2 and 4 can be divided by 2. 2 divided by 2 is 1, 4 divided by 2 is 2. Multiply straight across, 1 times 2 is 2, 1 times 3 is 3. That's my answer, 2/3. All right, let's do the next one. We have 5 divided by 1/10. So I'm going to change this to look more familiar. I have 5, and I'm dividing it. That's this big fraction bar. I'm dividing it by 1/10. Now keep in mind, 5 is the same thing as 5/1, so I can write that like this. And I want to do keep, change, flip. So keep the first, change division and multiplication, and flip the second. Now inspect the diagonals. I don't see anything that we can divide out on either diagonal. So I can just multiply straight across to give me 50/1. But remember, I don't have to put over 1. I can just write 50. 50 divided by 1 is just 50. Okay, let's do the next one. Just getting some practice here. I think that's our last slide. So we have 2 more. Let's see. Okay, so we're going to keep the first fraction, 9/17, change division and multiplication, and flip 4/5 to 5/4. Now we inspect the diagonals. 9 and 4 don't have anything that divides both of them, except 1, of course. And then 5 and 17 don't have anything either. So we just have to go straight across without cross-reducing. So 9 times 5 is 45 on top. 17 times 4 is 68. And that's our answer. All right, last one. 1/3 divided by 4. So keep in mind, 4 is just 4/1. Keep, change, flip. So I keep 1/3. I change division to multiplication. And I flip 4/1 to 1/4. Multiply straight across. I don't have anything on the diagonals that I can simplify, and I get 1/12. All right, so that is our lecture on fractions. Hopefully this made sense to you guys. Thanks for watching.